Okay, so in 9.1, we're going to talk about the Pythagorean theorem. So you've probably heard of this before, but it's a squared plus b squared equals c squared. So this applies to right triangles where a, b, and c are the different sides of the triangles. Okay, now c is always going to be your hypotenuse. So it's always the side that is opposite from the right angle, across from the right angle right there. Okay, and then our A and B are going to be your two other sides. Usually we call the sides of a triangle a leg. So your two other legs will be A and B. It doesn't matter which one is which. You'll get the same thing either way. Okay, so we're going to use this Pythagorean theorem to solve for the sides of a triangle. So let's look at example number 1. We have this triangle with our legs being 3 and 4, and we don't know our hypotenuse, so that means that's the side we're solving for. So we use a squared plus b squared equals c squared, so we're solving for c. So we don't know what c is, but we do know a and b. And again, it doesn't matter if 3 is a or b, as long as 4 is the other one. So I'm just going to say 3 is a and b is 4. So we have 3 squared plus 4 squared equals c squared. 3 squared is 9 plus 4 squared, 16 equals c squared. Okay, and then 9 plus 16 is going to give you 25. Okay, now since we're solving for c, we need to get rid of that square, so we're going to do our square roots. So we get 5 equals c. Now technically we get plus or minus 5, but it doesn't make sense to have a length be negative 5. You can't have a negative 5 length, so we're just always going to be using the positives for our values. So our c value is 5. Okay, and then one quick vocab word. This is what we call a Pythagorean, triple. Okay, so it's when you have 3 whole numbers in the Pythagorean theorem. So a, b, and c are all whole numbers. There's no decimals or square roots or anything. They're just all whole numbers. Okay, let's look at the next example. We have, for number 2, our legs are 10 and 5, and then our c value, our hypotenuse, is the one we're looking for. So pause the video, try and find it, and then press play to check your answer. Okay, so you should have tried to find c. So when we're plugging in a squared plus b squared equals c squared, again, it doesn't matter if 10 is a or b, so I'm just going to say a is 10, b is 5. So we get 10 squared plus 5 squared equals c squared. Now 10 squared is 100, 5 squared is 25, and 100 plus 25 is 125. Okay, so we're going to do our square roots. Now this is where the square root of 125 doesn't have an exact root, so we're going to have to simplify. Okay, so this is where we make our tree. So what multiplies to 125? Well, we have 5 and 25. Okay, nothing multiplies to 5, but 25 is, is 5 times 5. Okay, and then again, our 5s won't break down anymore. So since we have a square root, we're looking for groups of 2. That group is going to pull outside, and then whatever's left stays underneath. Okay, so our c value is 5 square root 5. Okay, is this a Pythagorean triple? No, because we have a square root in our hypotenuse, so it's not going to be a whole number. Okay, let's go down and do another example. So this time we are given c, right? C is 20, and we're given a is 12, but we're looking for b. So when we're plugging into our Pythagorean theorem, we have a squared is 12 squared plus b squared, we don't know, and then c is 20 squared. Okay, 12 squared is 144. 20 squared is 400. So now we want to solve for b, so we're going to subtract the 144 and get b squared equals 400 minus 144 is 256. Okay, and then we'll do our square roots. The square root of 256 is 16. Okay, if you don't know that, you can break it down and you'll get the same thing. But so for our side b, we should get 16. Okay, now is this one a Pythagorean triple? Yes. It has all whole numbers for our Pythagorean theorem. A, B, and C are all whole numbers. That means we have a Pythagorean triple. Okay, last example, number 4. Well, this time we're missing a. We're looking for our a value. Don't know what that is. And then our b is 7. So we're going to have 7 squared equals c is 13. So 13 squared. Now 7 squared is going to be 49. 13 squared is 169. We want to get a by itself, so we're going to subtract that 49 over. And 169 minus 49 is 120. So now we just need to do our square roots. A equals the square root of 120. And let's see if we can break that down at all. Well, 120 is 12 times 10. Okay, 10 is 2 times 5. 12 is 4 times 3. 4 is 2 times 2. So we have one group of 2's, but then we have 3, 2, and 5 left over. So we're going to pull the 2 outside, but under the square root we have 3, 2, and 5 left over, and we're going to multiply them together. So 3 times 2 is 6, times 5 is 30. So our a side is going to be 2 square root 30. And this would not be a Pythagorean triple because it has a square root in it. We don't have whole numbers.